So what we need is some way to say, if this part of the query, let's ignore this part for now, but let's just at the moment just take a look at this part. If this part of the query pushes an on error out, we don't want it to get past this part for this particular client, because if it does, then the whole query is being torn down. So what we could do is we could use, now if this was imperative style code, what would you do? An error is being thrown. How do you stop the error from propagating? Well, you would catch it, right? Not surprisingly, there's an operator called catch in Rx. So typically when you use the catch operator, you're not just specifying the source, but also the kind of exception you might expect. That's important, right? If you're doing something where, if you're dealing with an API that throws specific kinds of exceptions, you should catch specific kinds of exceptions and handle them specifically in the ways that make sense for that type. In our case, we really don't know up front what kinds of exceptions that we could expect from this send password request async, but we do know what kinds of exceptions we could expect from timeout. Timeout's always going to throw a timeout exception. So we could catch a timeout exception specifically if we wanted to. But we don't really have to in this case either, because we know that the result of catching any exception is going to be the same. We're just going to call dispose on the client, right? So we don't have to catch any specific kind of exception here. So if we look at this overload, all we really need to do is pass in an observable, which is the observable to continue with when we catch the error. However, notice that we lose the error itself if we use this overload, right? We won't have the actual exception in scope. If we use this overload, however, we need to specify an exception type. We could specify the base class if we wanted to, and then in the function handler that we pass in, the exception that is caught is passed to us, but we still have to return an observable to continue with, right? The observable for catch continues the observable. It continues it because, remember, we're not terminating the observable here. That's the point. We don't want to terminate it. So catch operator gives us a chance to continue with more data if we want to. We could continue with an observable that has no data in it, so it just technically just ends right there, which actually is exactly what we want to do. But we could continue with observables that have more data, or repeat the query, and there's a whole bunch of other options we could do here. But for now, we just have a very simple problem to solve, which is how do we just call dispose and then go away? Make this sub-observable, right, this sub-query just go away, and have the outer query still alive. And that's pretty easy for us to do. So first of all, we need to specify the source of the observable that is the input that we're catching an error on, potentially. And then we have to also specify the type of the exception. And I'm only doing this because we want the exception in scope, right? Because we'll probably want to log it at the very least or do something with it. So now we could take the exception, let's call it EX, and there's two things we want to do here. Now, we could expand this out in a lambda and just, perform the action here, or what we could do is call a method. That would remain more declarative, right? We don't have to care how this happens. We just want to know what needs to be done here. We want it to read like the spec. So reading like the spec is, terminate client. Now, the only problem with this is that notice the catch operator passes in the exception. Let me just get that IntelliSense back for us again. It's not giving it to me, and I'm not sure why. All right, let's just do it this way. Have it your way, Visual Studio. So you'll see the function gives us an exception, but it doesn't give us the client. Why doesn't it give us the client? Because it has no idea what the client is. It's receiving an on error notification from an observable of string, right? That's what the password return is. It doesn't know what a client is. So it's up to us to create a closure around all the data we need in order to perform this operation. So I'm just going to undo that to get it back to where it was. So yes, we want to call a method called terminate client, but we need to generate the method with some context, with some data. Again, because we're in this query comprehension syntax, we have this client variable, the thing that sort of triggered all this, and there'll be potentially multiple clients with multiple each client having its own subquery. But the client that's currently in scope when this code is running is the client that triggered the send password request async method, which then also failed with an error or a timeout. So we could reference that here. It's in scope. We could just do something like this, terminate client, and pass it to the client. However, remember what catch is. Catch is a function, requires a function passed in that accepts an exception and returns an observable. So terminate client has to return a function that, when given an exception, returns an observable. So for the functional programmers out there, this looks very much like a partial function application, right? It's like this curried form of a partial function. This is actually kind of an interesting problem that I think people run into it and they're just very confused how to solve this problem. And it turns out it's like the bread and butter of functional programming. So I love that about this kind of problem. It's so interesting to me that functional programming solves this problem in such a simple, elegant, and common way, yet as object-oriented developers, we kind of fumble around this a little bit and might end up doing some kind of weird stuff here. But what I'm about to do, I would argue, is actually probably the nicest way to do this. And the reason why is, again, we're trying to remain declarative here. Notice there's no lambda here. We don't have to put a lambda here. We'll hide that away somewhere where we don't really want to see it. Here, it just reads like the spec with arguably, maybe a little bit cluttered with this kind of having to specify these generic type arguments, but so be it. This is the static compiled world we live in, so the benefits outweigh the costs for that, I would argue. But anyway, if we read it from top down, we see sending the request, timeout from 2 minutes, although you can see the order here switched a little bit. That's the kind of thing that you'll see happen a lot and when you're writing the queries versus the spec. The spec doesn't depend on order so much because a lot of the time you'll write that you want to do X, Y, or Z, and Z depends on Y, but Y wasn't defined until after, and so because it's English, you can make those kinds of weird logistical mistakes or something. But when you're writing in the program, especially imperative style, or in this case it's declarative functional style, query style, but it still reads like an imperative style program and actually functions like that in a sense that you can't consume a variable that you haven't defined yet. So we have to have the client first. And then when we call this function, we have to call this function first before we could apply the timeout to it, before we could catch it to do, the same action for both of these. So anyway, you end up seeing some reversal in the order sometimes, but I would argue that doesn't make too much of a difference, right? It still reads like the spec, even if we have to change the order of some things. So anyway, so let's implement terminate client and see what happens. So if I generate the method and I go to the definition, it doesn't know what to do. Surprise, surprise. But we know what to do. We need to return a function that takes an exception and returns an I-observable of some continuation type, which in our case, it has to be the same type as the input, I believe, right? So it has to be a string in this case then. And it takes a client as input. Yeah, there we go. Now, it doesn't like this, though, for some reason. Let me see. Did I do something wrong? Probably. Cannot convert from function exception observable string to function exception observable of client. Oh, because I put client here. My bad. It's a string. There we go. So I just typed the wrong thing. Ooh, and now I don't have to type this. It's inferring it. Oh, look at that. I spoke too soon. There you go. It infers it because obviously it knows how to infer this. We're either passing in an observable or a function of exception to observable. Clearly, it's the second one, so the compiler is able to infer it. Even better. So there you go. This is a way to catch on error without having the outer observable terminate, and also remaining declarative and capturing any state that you might need in order to perform the operation that you need to perform. Right? So what does terminate client actually do? In our case now, we might even cause some side effects here with the logging the exception, right? For example. So, but we have to return a function here. So what we'll do is we'll just return the function like this. We'll say, given an exception, goes to, and now we can do whatever we want. Actually, we can even do it like this. And then we have to return an observable of string. What is our observable of string going to be? It's essentially represents a password. So after you catch an error, what password do we return? None. We have an empty observable of string, meaning that it's an observable that has no data at all. It just immediately, when you subscribe, it immediately calls on completed, right? It's an empty observable. So that doesn't mean 1, it means 0 notifications, right? And there you go. Now the compiler's happy, but we also wanted to do some other stuff, so we'd probably want to log the exe, use system diagnostics trace, which we can't because we are in a standard .NET Standard library. So we'll, again, diagnostics is a cross-cutting concern. We'll implement a nice little generic trace observable or something that we could deal with in the future. So for now, it's going to be something like, trace error ex, something like that, maybe with some message. And then also, we want to dispose of the client. That's pretty important, right? Kill the socket connection. As a matter of fact, we might want to kill the socket connection as soon as possible. Dispose should never throw an exception. That's just a part of the contract of dispose, and the general .NET contract that all of our expectations. So I'm not going to try catch around this. We'll just make sure that we honor that contract when we implement dispose. So it won't throw an exception. If it's going to potentially throw any exceptions, it's going to catch them internally and just log them, because there's nothing really more that it could do with it. Obviously here there's nothing more we could do with it anyway. We would catch it and then just log it anyway. So it won't throw an exception. Then we'll be able to just trace the error after it, and then we'll return an empty string, which indicates that we're terminating the client but not continuing with any useful information.